which is, of course, a work in progress. It works, but has been testing a lot of networks to make sure that it actually works. So back in 2015, I started with this project just to make my job easier, my day-to-day work easier. It was written in Bash. And then at some point, you realize that your code really sucks when it's in Bash and you want to do a lot of things. So I had to make a decision and rewrite it in Python. And right now it's able of scanning for Windows host, FTP, all of that, enumerating all of these, and at the end running poisoning credentials. I will not go into detail about how it does this, but we will see it in the demo. So why did I do that? First of all, I needed to satisfy my need being a hacker, to create something, create something which I consider cool, and something which I can share with the community. Raspberry is very cheap, it's expendable. If we put it at a client and we're not able to retrieve it, we don't mind. And I couldn't find anything that fits my need. I could find stuff that runs a lot of code automatically, but being an ethical hacker, I couldn't risk running something in a corporate network that it might break something, might exploit something, or do anything that I'm not really sure what it's doing. So when I come in front of the client, I want to make sure that I know what I did, and if I did something wrong or something dangerous, I'm going to be in a position to explain it. When you're doing red teaming scenarios, you have very limited time. If you want to get in and get out, you don't have the time to plug a laptop, usually of course. You don't have the time to plug a laptop, you don't have the time to execute commands, make sure that the network works okay. So with the Raspberry, I'm able to just drop it and leave and make it do the hard work for me. At the end of the day, we want to show to the client the emphasis that you need to put on physical security. Cyber, we all understand. People, we all kind of understand, but physical security, we usually don't correlate it with hacking approaches. We tend to believe that having some controls is effective. So as I was looking for my research, I found many distributions which are similar, like the Raspberry Pi, the WarBerry Pi, Pwn Express, Pwn, which is very famous, and many other projects were available online. But then again, I was still having the same problem of not being able to know what exactly the script does in the background. I had the biggest problem being the price. I don't know if you know about the prices of some of these products. They're very expensive. So this gave me some more power to keep going and to complete my project. And just to give you an analogy, we all use Nmap during our penetration test. I use it a lot. And if you do a basic Nmap of the most simple scan you can do with Nmap, then you're running scans for 1,000 TCP ports and approximately 1,000 services. And this is a lot. This is a lot, and it's very heavy inside the network, especially if it's a big network. When you're using a WarBerry, which is customized, still makes use of Nmap, you're scanning for 53 TCP ports, 4 UDP ports, and about 50 services. So it's significantly more cover than Nmap itself. If you're running Nmap with a standard script, you're running about 115 scripts inside the network. Some of these may not be safe. Some of these you might need authorization. So you don't really talk with the client. You just put this parameter, run it, and you hope for the best, which is not the right approach. If you do that with WarBerry, you only run 16 scripts. Of course, if you compare 1,000 with 115 with 16, these are less scripts. It's not that it's 115 scripts inside those 16. But what I did, I went through and I researched which scripts do I really want. There are some services I know that I will not find in a client environment for sure. So why not exclude those every time? But nevertheless, the choice which one to use It depends what type of engagement you're doing. You might want to scan for 65,000 ports. And it all depends. So it's not that the WarBerry is better than Nmap. And I rely heavily on Nmap. So I like it. As I said, the choice comes to what you want to do. If you're attacking a network, you can do this, which is a full-blown attack. Or you can do a tactical attack, which you try to remain hidden. If you're running a full-blown attack, you have some benefits, which is quick. You run some tools, you get a lot of shells, which is the best thing for a hacker penetration tester. But then again, you make a lot of noise. You do not have a lot of control on what's going on. So, for example, if you're running Nessus, you're not really sure what kind of plugins you're running at any given time. If you're doing a tactical attack, you remain stealthy. It's more controllable, but then again, the scope is smaller, and it requires a lot of skill to manage to get a shell. So these are some pictures I took from engagements that we use the Raspberry. In this case, this is a very common setup in offices. Okay, so you have a stack of a box of paper right next to the printer. So we built a box with a fake bottom that sits on top of the Raspberry. We filled it with paper closely. People were using it, so taking out paper. And by the time they went to the last box of paper, it was too late, because the Raspberry usually takes a couple of hours to enumerate the network. And this is inside the server room. It doesn't show very well. So it was, we put it behind the server on the top of the rack, and we just left it there. Okay, so these are nice scenarios, but how far can social engineering and red teaming take you? Is it feasible in the real world? So just to make it more fun for you, can it get you front row tickets to a Champions League game if you do a good enough social engineering? So back in 2008, Olympiakos Piraeus was playing Anorthosis from Cyprus, in Cyprus, and I had tickets for the Anorthosis side. But it was in August, it was very hot, and this was during the warm-up, and I was on this Anorthosis fan side. During the first half, I decided that I want to get closer and maybe get inside the field, inside the stadium. And at the second half, I was standing right behind the player, being one of these guys. How I did it? It was basically pretending to be a photographer. I had a small Sony Cyber shot, if you know which one it was, in 2008. It's this big. So I just told the security, I really need to do my job. I will get fired. So he let me in. He said, get in, but stay here. Don't go anywhere else. So obviously, social engineering can take you far. It can take you very far, and you can plug a WarBerry very good.
Very fast.
You know that guy that was Georgians? One of the very good players for Olympiads. When you're using a WarBerry, though, you face a lot of problems, like port security. So how to overcome this? If you have port security, which one MAC is associated to a single port inside the network, the WarBerry, as it is now, it can help you because you have two Ethernet inputs. One can be used as input, one can be used as output. If you use bridge utilities, you set both IPs to 0.0.0.0, then you have a transparent interface, then you are inside the network between the host and the network port, and it will work. Many other ways to do it, this is one solution. If you're having a static IP, that's easy. You just assign yourself a static IP. WarBerry does that automatically. If you have MAC filtering, then just sniff all the MAC addresses in the network, the associated IPs, and just mimic one of those, duplicate it, and you will be inside the network, most probably. And this is the hardest security to bypass, which is network access control. So basically, you need to authorize yourself to the network. But the problem is that many devices do not have this capability. Like, let's say, for example, printers do not have the capability of supporting NAC in many cases, not always. So if we look for these exceptions, and then we find the IP, we find the MAC address of the exception, maybe we will be able to bypass the NAC in place. This is not a silver bullet, it doesn't work all the time. The WarBerry tries to do that automatically, so we have a database of keywords to search for. If it finds a keyword like printer or whatever else, which looks like an exception, takes the hostname, changes its hostname, changes its MAC and its IP. So you just mimic a device and network. So let's do a demo. I hope you, in the back, you can see it well. Pray with me that it works, otherwise just make fun of me. So this is the most simple network that I'm using because everything is over Wi-Fi. And I have a video of static IP bypass video if you have the time. So I'm connected to the WarBerry via this over Wi-Fi. Usually when I leave it at the client, this also has a 3G USB stick on it, which connects back to a service which I will show you. It's called Weave. It's an online service which it provides reverse SSH to your device. And it's very nice because it also has an iOS application, iPad application, and you can see if any of your WarBerries are online. That means you're doing well. So.
Can you zoom in the tree?
Does anybody remember the shortcut for zooming in?
Bigger than
Maybe change the settings to the port size. Yes. Right click, change settings.
More? Now that we know the way. Maybe the demo will not work. But it is actually change the phone. Whoa, let's go crazy.
Nope, that's it.
One, two, sorry.
Yeah, that's it.
It's at the bottom.
Yeah. So this is a WarBerry.py script. It requires sudo rights to run. If you do -h, you can see the help page. You can do a lot of things, right? If you want to just run poison inside the network, if you want to poison credentials, just run with the malicious mode on. You can specify the intensity of the scans you want to do. You can specify the interface. By default, it's CTH0. In my case, because I'm using wireless, it's going to be WLAN 0. I'll try to walk you through. So first of all, it checks if it has valid IP address. If not, it runs other scripts. It checks to see the net mask in order to scan the entire network. And it begins by sniffing packets using Scapy, the Python Scapy module of Python, and it tries to capture any interesting traffic from that network. Then it enumerates the names, and it found that there's an interesting name called DC1, which I have in my database is interesting. So it's changing the hostname from WarBerry to DC1. So right now the hostname is DC1 and you appear everywhere as DC1. So you have two DC1s. And then after we enumerated, we did the sniffing, it starts enumerating a bunch of services using threads, TCP and UDP. And then depending on the results that you have, it starts enumeration of those, for example, if it found UPnP, like there, it's going to run scripts only for UPnP. So you don't run random scripts that you don't need. You only run scripts based on the result you had from open ports only. So right now it's doing SMB shares enumeration just because of the ports that were open on the Windows machines. If it finds, for example, SQL, it's going to do only the SQL enumeration modules. So you save a lot of time and you save a lot of network traffic that you were normally going to send inside the network. Enumerating shares takes some time. There were some tries and some attempts to spoof the source IP. I released a version a couple of days ago and I took it back. I changed my mind because it's...
While scanning for shares, I saw in the output at the beginning that say no internet connectivity.
no external.
No external, but
yeah.
did you, can you, for example, implement some kind of egress buster to check via a lot of ports which port are open to the internet? Is it a feature?
I don't need that port.
You don't
anyway. It doesn't send anything outside because at this moment I have 3G connectivity to the WarBerry anyway. So that's the covered channel that I'm using. So the external, the checking of the external IP, no, never. It just checks if you have access, then, and I connect via 3G. Maybe I want to download some files for post-exploitation.
Yeah, okay.
That's the only way, the only reason why I'm checking for outbound traffic. But shares, right now I'm scanning the internal network, which is .8. Any questions so far? So there are 2 or 3 scripts which run just because those are Windows machines, and Windows machines are nice when you're doing penetration tests because you do your work. And I'm enumerating HTTP titles because after it completes, I want to see what type of applications I'm against. If I want to do some escalation, if I want to exploit more machines, maybe that's an avenue that I can use. I'm also checking if there is a web application firewall on each of the web servers we found before. And then lastly, we're doing operating system enumeration, just to know which kind of targets you're against. So,
can you explain how the port security can be bypassed?
Which the port security, just the port security.
When
just a second, before I miss my
okay.
cue. So we're at Bluetooth enumeration. It also enumerates Bluetooth. Just turn it on for now. This is useful for phishing attacks later on. So you will see that it found my iPhone. So right now you know that somebody inside the company is called Yiannis and has an iPhone with this MAC address. A lot of attacks to perform, phishing, from if you know if it's an iPhone 5 or whatever, you can do some exploitation and get access to the phone. So this is not an active attack, it just sniffs the names, MAC addresses for future steps. It takes some time. I left it on purpose to run for some time to capture as many Bluetooth devices as possible. And the last part that it's going to do is do a wireless network enumeration. So that, combined with something like Wi-Fi Fisher, where you can do phishing attacks against wireless networks, if you know the names already, saves you a lot of time, and it's easier to exploit, to launch the exploitation. Very nice. I was expecting something like that. We need some bunch of guys getting together in the back. So, okay. Just for the pictures. So it enumerated the wireless networks as well. Okay. And then we get into poisoning mode. If you know responder, it does poisoning, let's say, so you're able to capture hashes. And then from there, if you capture the hashes, crack them if they're NTLM1, NTLMV1, you get access to the Raspberry via 3G and just launch your attacks. So this was a demo with the DHCP. If you give me some couple of minutes, we'll get back to you.
No problem.
Just, you have time for the second demo?
8 minutes.
I'm just going to show the difference. I will not show the enumeration. Now we don't have a valid IP. Just clearing out the previous output folder. Here I'm just showing that everything, all the VMs have a static IP. Module. So right here, we can see that the IP is not valid, and we want to check if we can bypass it with the static IP. So I'm scanning the network for IPs. I found 4 IPs which are in use and they are valid, and then the subnet. And I create the subnet based on the IPs that I found. We make a list and we exclude the IPs which are in use, and then from the remaining IPs, we select one randomly. We set the IP statically randomly, and we ping one of the live IPs. If we get a response, that means it's a valid IP, and we disregard the rest. Otherwise, we proceed with pinging the next, setting a different IP address, and all that. So this is a network sniffing module. We found an interesting name called server. It does exactly what I showed you before. So in the second case, I had a Cisco 800 series. Cisco 800 series, which was doing the static IP and DHCP for me. And everything is saved in a folder called the results. If you extract that folder and you place it in the reporting module, which is available on GitHub, it creates a report for you, which you can export to PDF. You have a nice report with credentials, wireless name, Bluetooth names, which machines are Windows, which machines have this port open, a different port open. And just some of the countermeasures. First of all, train your people, because in order for us to get in, we need people that will bypass. Use port security and NAC whenever you can. Go beyond default Windows login, because we see that most of the time you don't appear in logs, which it's scary to think that some other malicious people do not appear in the logs. Run the necessary services, patch and harden, and for responder, basically it does MPNS poisoning, it does LMNR poisoning, which is the successor of the previous one, this one, and WPAT poisoning, which these are enabled by default on Windows, so you can disable them. This was a great reference I found the other day. It explains exactly what to do, and saves you from a lot of trouble. And many thanks to these people, because they helped me a lot. And if you know something, just share it. It's good to share. I learned everything from others. To come back to your security, to your question about security. Basically in this situation, we use one end coming in from the port to the WarBerry. The other end going from the WarBerry to the host, to the legitimate host that was supposed to be there. Example, printer. If you create both interfaces, if you set them an IP, you create a bridge called MITM, then you can be a transparent bridge between the port and the host.
If the port is configured to be an access port, not a tunnel port, then it's not possible. Okay.
There are other types of things you can do, but usually we target devices like printers. It's the easiest way. They get most of the access on the internet, and usually it's configured enough to be in a network segment that they're not supposed to be.
And it is easier to find the MAC address of the printer, so you can change the MAC address of the. Okay.
Any other questions?
Again, thank you very much.
Thank you.